All right, okay, we're back, part 2. So linear systems, word problems. So if you missed part 1, you can take a look at the link I'll provide it above. Started with basically 3 examples there. I'll continue with another 3 here. And these examples are basically just word problems where I'm transforming them into a linear system. So linear system is basically just 2 equations with 2 unknowns. So that's what we have. Now, and it is kind of geared towards grade 9 and grade 10 students that are going to be maybe working on these. Now, of course, you might be working on these types of problems later on as well, okay? Maybe even in college or university or something, and you're just trying to refresh. So here's the first problem that I have for you. So it says, sales per item are equal to costs and a markup. Okay. Assume that markup is 40% of costs. If sales per item are $100, then what was the markup for this item? Okay. Now, you don't have to know anything about sales or costs or markup, but that's kind of the beauty of these, right? That it kind of opens up your horizon to try to see, if you can solve these types of problems. Because often students might come up and say, I don't know, I've never heard of these things. Well, exactly. That's why you're trying to learn them, right? So you want to be able to expose to some variety of these. So let's take a look and see how we can tackle a problem like this. So it says that sales, now it says per item, so I'm going to assume everything is per item, is equal to costs and a markup. All right, so I'm going to write that down so for myself. So I have sales. Now let's say costs, I'm going to say cost, okay, and then markup is M. Now they give us what the sales are at the end, so it's not going to be S at all. Okay, so now assume that markup is 40% of costs, and then sales per item are $100. So from that first sentence, so sales are $100, so we have basically $100 is equal to costs plus markup, or, you can rewrite this as just cost plus markup is equal to the sales of $100. How you write it is up to you, right? But this is kind of our first equation that we have. Now it says, assume that markup is 40% of costs. So markup, so M, that's equal. So we have markup is 40% of costs. So it doesn't say 40% more than costs or 40% less than costs. It says 40% of costs. So the word of just means multiply. So here, all that it is, so 40% is 0.4 multiplied by the cost, and the cost is just C, or at least that's what we designated as. And that is your second equation. Now it says, what was the markup for this item? Okay, so what was the markup? So we want to be able to solve for M. Okay, so we don't really need C, we're solving for M. So it's kind of convenient here because markup is 0.4 of cost. So we can substitute markup back in, we can find the cost, and then we can substitute back again and then find the markup. But because they're asking for the markup right away, I can take my second equation here, or my first equation here, and then just simply isolate. So in this case, let me take this one. So I'll kind of change things up here. So I'm going to isolate for cost. So cost is equal to 100 minus M. Okay, so I just change that in. Now I can substitute for the cost, and I will find that markup is equal to, so 0.4, and then I have 100 minus M, and notice now you have only one equation after that substitution and one unknown. All right, so it's going to be M equals, I can bring this inside of the brackets, so that's going to be 40 minus 0.4 M. So now bring that over on the other side, and I'll get M plus 0.4 M is equal to 40, or simply 1.4 M. So don't forget there's a 1 when you're collecting these like terms. And I have that. Now dividing both sides by 1.4. Okay, and there we go. We can solve what m is. Now I don't know if you can use a calculator or not. I mean, it's great if they don't let you use one, just to force you to kind of go through the arithmetic, but I'll save us a little bit of time. So the answer here, so it's not a pretty answer, but remember this is money, right? So this is dollars. So if it is dollars, I'm just going to round it to the cents, so to 2 decimal places. So it's $28.57 approximately, right? Most of the time when you're in kind of high school in the beginning, they kind of give you nice numbers, everything works out, but that's not always reality in the real world, okay? But that's how you would solve for the markup. Now they only ask me for the markup, so that's all that I'm going to solve for. If they wanted the cost, I can always plug it back in and then get exactly what the cost was. All right, so this is our example number 2 in this video. So try it, pause the video, do it on your own, and then come back. So we have half of the energy consumed at lunch was equal to 285 less than the energy of the dinner. If the total energy consumed between lunch and dinner was 1,185 calories, then how many calories were consumed at lunch? Okay. So now they want to know how much we consumed at lunch. So we're going to be solving for lunch. Now, again, so as you start this, you can, technically, if you're doing this, sometimes teachers will ask you to say, let, and then define your variables that you have. So now we have basically energy between lunch and energy between dinner. So how many calories they have. So we're solving for energy. So I can set, energy. So energy E. I'll put a subscript L. So this is the energy at lunch. So energy at lunch. And then I can put energy at dinner, D. And so here I can write energy at dinner. So those are the two. And now notice that if the total energy, so we know that from that second one, so the energy at lunch plus the energy at dinner is equal to 1185. So that's one of the equations that we have. Let me change the color here. So now our second equation is going to be our first one. So it says half of the energy consumed at lunch. All right, so half, so that's 1/2 of the energy consumed at lunch, okay, was equal to 285 less than the energy consumed at dinner. All right, so energy at dinner, so less than 285. So this is what we have for our second equation. And now we want to be able to solve this for lunch, how many calories we had, so how much energy we consumed at lunch. So in doing so, if you're solving for lunch, that means you isolate one for the dinner and then you substitute it back in, right? So this one is again the easiest one. So this is ED is equal to 1185 minus energy at lunch when I isolate it for that. Now I can take this and substitute it in here. So what do I get? So I'll have 1/2, okay, energy at lunch equals to, when I substitute, I'll get 1185 minus EL, right? You can put that in brackets if you like. Okay, so brackets, minus 285. And now we have one equation with EL, one unknown, so we can go ahead and solve. All right, so I'll bring this EL over to the other side, so that's going to be EL plus 1/2 EL equals 2, and then on this side I have 185 minus 285. Okay, so that's what I have there. So now I can go ahead and do that. So 1185 minus 285, this is 900. And then EL plus 1/2, so that's going to be 1.5. Now I can change that 1.5 to decimal, so I have that. Now dividing both sides by 1.5, I'll know exactly. So it's going to be 900 divided by 1.5, and I get that many calories. Okay, so that's how many we had for lunch. All right, so this is what it would have been, okay, in terms of our lunch. Now, if you wanted to know the dinner, you can substitute it back in for dinner, and you would get 1185. All right, okay, so you can go back in here, okay, and substitute in here. So it's 1185 minus the 600, and then you would know exactly how much they had for dinner. All right, so there you go. Okay, so that's what we have there, okay, in terms of trying to find out, okay, so these particular numbers, okay, and then what they give us. All right, okay, so now last example of this video. So this one, so it's interesting. So here it is. So it says, Sabrina, after her practice on Tuesday, went into a store to purchase milkshakes and waters. All right. She bought 3 milkshakes and then 4 waters that particular day. The total purchase for that order was $22.50. This is interesting and definitely different than the previous ones. So notice we do have milkshakes and waters. You know, we know how many we purchased and we know what the total was. Now, after the practice on Thursday, so this is the second day, so Tuesday and Thursday, she went to the store and she bought 5 milkshakes and only 2 waters. Now for that day, she paid $20. And now we want to know, how much did each milkshake cost? So again, so you can define, you know, you can say let, and then you can say milkshakes. Okay, let these be milkshakes, so the cost of the milkshakes. And then let's say waters, let's say W, okay, cost of the waters. So those are the 2 that you would have. Okay, so you can do that just to separate them. You don't know how much they cost, but you do know the totals. So notice from the first sentence, so here, so sorry, from the second one, so she bought 3 milkshakes and 4 waters, and the total purchase was this much. So we had 3 milkshakes. Now we don't know how much a milkshake costs. So 3 times a milkshake, whatever it is per one, plus 4 of the waters was equal to the total purchase of $22.50. All right, so that's what we have there. Now those multiplications are not really needed there, so you can just write it like that. Now the second one is we have 5 milkshakes and then only 2 waters. So we have 5 milkshakes and only 2 waters, and that cost us $20. So notice 2 equations, okay? So it's a linear system, and now we can go ahead and solve. Now, what do they want us to solve for? How much did each milkshake cost? All right, so we want to know the milkshake. So that means if we want to know the milkshake, let's use the elimination method. All right, so I'm going to, okay, and now for the elimination method, if you forgot, I'll put a link because these are integers. So I'll put a link above to the elimination method on integers. So I want milkshakes, so I'm going to get rid of the waters here. And notice I have a 4 and a 2. So I'm going to be multiplying my line number 2. So I'll multiply this line by 2. All right, so this entire line. So that I have basically my coefficient of 4 on the W. And then I'm going to subtract. So that's going to give me, so if I multiply, I'm going to get 10m plus 4w is equal to 40. So that's that. And then, so this is my equation number 2 prime. Okay, I just changed it by 2. And now what I will do is I will take equation 1 minus equation 2 prime. That's going to get rid of my w entirely, right? So what do I have? I have 3 minus the 10, so that's going to be negative 7m is equal to, and then 2250 minus 40. All right, so it's going to give me a negative there. And it's going to be negative, I guess, what is it, 1817 and a half. That's that. The negative, so this negative and this negative will just cancel itself. And then you can, that's because you can divide both sides. And then you'll find out exactly how much those milkshakes were. So let's take a look. So we have 1750 divided by 7. So each milkshake was $2.50. There you go. So that's how you would set this one up. All right. So another 3 examples for you. So now between part 1 and this part 2, you basically had seen 6 examples. All right. We'll see you in a future video. Bye, everyone.